Hello everyone, we've built TMAC, Total Material Appearance Capture System, a device designed to transfer real-world surfaces like book clay, sway, linens, curtains, etc. to virtual realm. Its tray is designed to take 1.3 by 1.3 meters big samples and one by one, as you can see here, 1 by 1 meter underlit scan area to take the translucency. So the aim is to be able to grasp the local beautiful movements of fabrics that really need it and be able to take like that full capture, but also be able to switch different lenses and be able to zoom in on much more repetitive surfaces to obtain much more detail out of them. So the device usually comes with the cover, and there's a sequence of lights inside that basically divides the material into important layers that are not visible and are not obtainable in a single photograph. Like for example, tiger stripes of the wood are represented by high frequency normal map. For example, the relief of book clay, like that, beautiful little bubbles, those are represented by displacement map that are derived from high frequency normal map. The lighting from underneath, for example, which is important for curtains or window shades, that's obtained by the translucency map and then alpha map. And for example, when there's something like a letter and it's completely not visible or is all gray, but it's sometimes more matte and more glossy, that's represented by roughness map. So in other words, it divides materials into layers that are describing the surface in with different maps to be able to relight it and use it in virtual realm. So let's scan a material. I'm going to just do close this one, put it in. Basically, in the usual production, you would have a cover and probably put it up on a table. In this case, it goes up completely out the tray, and then you put inside. So for the presentation purposes, I'm going to turn the lights off in this room. I'm gonna blind it, and I'm gonna turn on the TMAC. So now, as you can see, the lights has been turned on, so you would see what's going on inside. And I'm going to go here on the computer and click TMAC import. So now it's looking for camera. In the properties, it's set up, and now it found the camera and we have the picture. So in this view, you can double click to actually focus on whichever area. And to check the focus, you would go and you can do the magnify, and you can actually turn on even matcap just to make sure that we're looking very sharp. So whenever we're happy with the crop and with the focus, we're gonna hit apply, and as you can see, the software is awaiting TMAC to be started. So I'm gonna head to the display on the TMAC and turn on the procedure. So now the TMAC is taking 20 photographs. It's based on photometric, cross-polarized photometric stereo system. It goes all around, and as you can see on the computer itself, we're already processing these raw information, let's say, into the maps. The whole capture takes 1 minute on the TMAC itself, and then what we would need to do to process it is to work within the TMAC Studio software to make the map seamless, and also to actually integrate it into the 3D software of the choice. And as we can see, the maps now are popping up. Meanwhile, they're popping up. I'm going to let the light come in again and turn off the device for the time being. And let's start processing. Now that the maps are in, let's take a look at them. The first one here is albedo. I'm gonna extend it, which is the color. Second one is normal map, which talks about the bumps and how the surface looks like. Another one is displacement, that tells how high the bumps go. We have translucency here that talks about the light going through, flat bad, which is the most flat one, and then we have the different angled one if we, for example, needed to extract a map with smudges from different angle. So let's go and process the maps in TMAC Studio. The TMAC Studio works in a way that anything that's important comes in resources, then we use tool to process it, and then anything that is coming out of the tool is actually in the generators. So in that sense, we can always revisit and we can always recompute and we can always compare, and it's non-destructive workflow. There are three main tools that we'll be using to make any map seamlessly tileable. One is reference-based color equalization, then it's normal telecentric or guided replication, and it's make tile. So there's a lot more tools in here that are supportive, like resizing, displacement to normal, compute displacement, high pass filters, etc. But those are the three tools that are most powerful and will be used the most. So first, let's actually use resize here, just to show like how the overall workflow goes. So I'm gonna go take albedo, take normal map, which we'll be using. Displacement we can compute from normal later. Let's take roughness, specularity. Actually, specular trash is the one I prefer. Translucency, and let's take flat bed as well. Let's make them 35% of the size. And for now, as we've said this, let's trash the rest of the scan. So this way, as you see, we have computed a node. If we double click it, we can actually revisit its settings. We can add more inputs or take away from it inputs and recompute it, and it's going to come here. So that's the general way, that's the general structure and how the application works. So let's first go to color equalization. Now, reference-based color equalization is great for gradients, removals, large, let's say, vignetting or reflections, recoloring, for segmentation-based flip-flop correction, or even targeted healing. So in this case, I'm going to take and try to run basically almost everything, except it should not be used for normal through that tool. And we can always work in two different modes. One is pixels, one is percentage. So this block size means how strong this is. Something like 20 to 30% is subtle. Something like 7 to 10 is medium, and something like 1 by 1 is super strong, or in other words, many times would look high pass. So that's much better to be used together with segmentation mask. I'm going to go with 7 and 10. And a reference area is actually setting where is the area that I want to take the reference and color from, because we'll be pushing that to all around. So we can work in central, or we can use floating. In this case, I'm gonna use central and say, hey, this is the color from the center that I want to push, and it's gonna take each map and apply each map to actually do that. So I'm gonna press OK, and as we can see, we have the progress bar rolling and all of these going. Now inside color equalization, there's going to be third mode as well, which is going to be fast. Currently, you can actually use normal flattening in the normalized node, which is going to give that fast. So albedo here, albedo after. As you can see, it's doing really good work with removing that, which is traditional. However, what we'll see here is that there's a flip-flop of perspective that we would love to tweak further on. Then we have the roughness, so roughness before after, that's pretty good. Specular, and specular, we can see that it left some of the edges there. What we can do maybe is take the specular again and just, like, you know, make it stronger, apply it again. And flat bed, so this one is really good, and this one is really flat as well. And specular, so specular looks like is going to be hard to actually completely make it completely right. So there is another tool that we can use, and we can use it actually to repair one maps when compared with the other. So we can use in other words, we can use the correlation between maps to repair, and that is normal telecentric, or in other words, guided replication. So this tool is very strong and can be used for perspective correction, for mosaic rebuilding of a matrix like patterns, can be used for normal map healing, guided healing, any map guided central reference based rebuilding, etc. So the gist of this tool is this. I'm going to set it to, which is going to be set anyways to as a default, to 20,000 blocks. And I'm going to say, hey, I want to correct my specular in this case. My specular, I'm not like fully liking it. And but I really think that flat bed is really good, or maybe even albedo is good. You can put multiple here as guides. So, and I'm gonna set it to 5 by 5 pixels. So what it's going to do is that it's going to take this area, which we can, by the way, again, set anyhow we would like, and it's going to chop it into 20,000 small random pieces. Big 5 by 5 pixel. It's going to actually do it on flatbed and find the most suitable way where to place it that matches. And when it finds it, it actually performs it on this map. So in other words, we're using one map to correct the other, but rebuild it from the pixels from the other one. So we have advanced settings, and we can use masks and segmentations. I'm gonna hit apply. So in this case, this one is fine. Roughness looks good. This one we're now repairing. This one yeah, this one is maybe we're using a little bit too much of the color equalization here, but I'm gonna keep it. Maybe we're looking too much high pass, but I'm gonna try to fix those. And so let's see that. So this was here, and that's after. So as you can see, it actually completely rebuilt it from the center based on a different map. And this is a really, really powerful one. So what we can do with it as well is, let's say, heal this normal map. So as you can see, we have some wrinkles here, and we can use a traditional ironing to get rid of it. So I can take it and, let's say, go to something like even 5, which is really small. You know, that's gonna get removed, but it removed all, you know, all the beautiful fluffiness of that map as well. So we can do that, or we can actually repair it in a guided manner as well. And to repair the normal map, I'm going to use a normal map healing here. There's also this like a flip-flop effect you can see because of anisotropy of material going on. So let me apply the normal map self-healing. Here we go. So now we've de-wrinkled the map, and we also repaired the flip-flop. And the last thing I'm going to show is the targeted healing of core equalization. So in here, we can see that we're pretty happy with this, but we have some splotches, and we can push those out. So I'm gonna take this trans and I'm gonna make it much stronger, something like 2 by 2. And I'm gonna say, hey, apply that super strong to only this region. So it's going to take a color from this region and apply it in a super strong way into the other region. And these regions, these work across. So we can use it for anything and everything. So now let's take a look. This is before. And this is after. So we're not fully there yet. Now with playing a little bit with translucency, this is the place where I was able to get it with the targeted color equalization. And now let's proceed to the last step. So I'm going to still polish a little bit the albedo here, because as you can see, it also switches the perspectives. So what I'm going to do is that I'm going to use, again, normal telecentric and repair that albedo with our flat bed, because that's the most flat one. And let's already start cleaning this up. So we don't need resize. The roughness here is good. This one we're using from normal telecentric. So I'm gonna clean that. This one here, that can go away. This can go away. That's right. This one was too high passed, and this one we've fixed here, so that's good. These guys we fixed. This one we don't need anymore. Albedo looks, yeah, you can see that we've been able to actually remove the perspective here, so we don't need albedo there. And the last thing here would be to create a nice displacement out of normal map. So I'm going to go to compute displacement, and let's do 0 and 50, which is usually, yes, pretty good. So now that we have all the maps ready, the last thing is to tile them. And as you see, the tiling here is like a flat line. So we have a module, make tile, where I'm going to go and pick all the maps that we're tiling, and it has a live pick like this one to actually take the 4 tiles where it needs to be. And I'm gonna switch this to, let's say, normal, so that we see Gizmo better. But we can also turn on the invisible path tiling, which actually is going to try to find this crooked line throughout to try to hide the path. And here you can set again the percentage. I'm gonna keep it 5 by 5, and you can also place it by the side. So let's, in this case, put it something like this. Hit apply and apply. As you can see, meanwhile, it's being processed. Yeah, oh, okay, so we have it already. And let's take a look on albedo. And there's one more setting here, which is path blending, because what you can see here is that it actually blended between the two, which we don't want. So I'm going to set this to 0, actually to 1 and 1. Click again. And this is a convenient way to reuse these nodes. Here we go. And right now it's going to be much harder to find that line where it actually hit it, because it's like a crooked line. So now it's completely invisible. So no longer possible to find a straight line. And yeah, that concludes the tutorial of and the presentation of making all the maps seamlessly tileable. I can go and export them. In 3ds Max, let's import maps that will be important to describe this material. So first of all is the albedo comp, which is our albedo. Now, if you take a look on it, albedo looks in color off towards what the reference is. That's hugely because we haven't had the cover on top of it, but as well, every material is going to demand certain pushes here and there to get the material right based on the reference that you're after, and of course the workflow that you're working within. So let's plug this albedo here. Next thing for this particular material is going to be definitely the displacement. So the default one is displacement 50. Let's take that one. And definitely normal map. Normal 250 is the one to go to since the beginning. So when we apply the material itself and start the rendering, let's actually start with the displacement. So I'm going to put it in displace. There we go. And you can already see, I'm going to make this bigger. You can already see the pebbles that are getting it in. I'm going to make the performance here a little bit smoother. Here we go. But it's definitely too much. So I'm gonna put this down let's make this 0.3. Yeah, that's much better. And let's put the actual normal on top. So I'm gonna put the normal and put it into base bump. Here we go. And now we can see that we're getting that structure that we needed already out of it. And you can see it in here too. So all is working here. We can adjust the strength of the normal map, but I like it pretty strong. So I'm gonna keep it like 4. So now with that, I'm gonna bring in the base. And as you'll see, now we're getting something that is resembling. We're probably a little bit too strong on the displacement. Maybe we're just like too close up. Yes, but we're getting a little bit of the color. So what I'm gonna do is that I have prepared this mask. Again, mask needs to be currently prepared outside. This one in Photoshop, there's a video on this. So I'm gonna just put it in and let's adjust it so that we're closer to where we need to be. I'm gonna take the Corona mix in this case, put it in a mix mode, put this to the top, our mask to the mix. Let's plug it in. So that's gonna be the white dots. And let's duplicate. And let's, in this case, take the Corona color correct, plug it in the base. And if we look at here, first of all, we need to turn off the specularity because there's no specularity on materials like this one. And now let's adjust the hue and exposure. Okay. Now we're getting something that's much more, and saturation more. Here we go. Okay, so this is good for this case. If I wanted to take it further, I would actually put the fall off on it. But when it comes to being close to how the fabric looks like, this is really close. Okay, so let's now switch back because now we've actually made the material pasta. One more thing that we could put in is actually the translucency itself, which is this one. That one we can always put in inside the translucency. And let's put translucency something like 0.1 so that we get that softness of the fabric. Okay,